So welcome everybody to Conversations of Species Credits. My name is Doug Bruggeman. I'm the president of Ecological Services and Markets. And we host this webinar. We've been doing it for over a year now. And we've had some really great speakers. And this is another example of really highlighting some great science to move policy forward. So at Ecological Services and Markets, we specialize in developing market-based approaches for sustainability with an emphasis on employing landscape scale techniques. So I want to thank our steering committee, including Greg DeYoung with Westervelt Ecological Services, Sarah Johnson with ERBA, and Donna Collier with Valencia Wetlands Trust. So the objective of the webinar, I'm sorry, one of those days. The objective of the webinar series is to create an open community to discuss successes and barriers in species markets. So by shining a brighter light on species markets, our goal is to create new markets and strengthen existing markets. So while our focus so far has been on regulated markets in the US under the Endangered Species Act, today we're going to learn about tools useful for assessing policy at a regional scale. So both the US and Australia have adopted the system of environmental economic accounting for ecosystem accounting as a way to compile and present data on economic and environmental trade-offs. So today we'll hear from Dr. Ferrier and Mokany, I screwed that up, sorry, Carol, on habitat-based biodiversity accounting to track change and inform decision-making. So both are research scientists with the Commonwealth Scientific and Industrial Research Organization. So for those of us in the US, the CSIRO, as it's referred to, it's kind of like USGS and the research side of the Corps of Engineers combined. So that sounds like I need to do a little housekeeping before we get going. So I just want to keep you guys muted as you come in. And so I'm going to turn it over to Dr. Ferrier.
Hey, thanks very much. Doug, can you see in my presentation and hear me all right?
It looks great.
Okay, that's good. Thank you. Well, good afternoon, evening, or even morning, everybody. My name is Simon Ferrier. Welcome to this webinar. I'm going to give you quite a brief and general introduction to the use of habitat-based approaches to accounting for biodiversity. And then I'm going to hand over to my colleague, Mokany, who's going to then use the rest of this presentation to give you quite a detailed description of how these approaches have been applied to a particular region in Australia, the Murray-Darling Basin. And that's work that has actually been funded by our Federal Department of Climate Change, Energy, the Environment and Water. Just getting my slide to move. There we go. Okay, so the global biodiversity crisis has been increasingly attracting a lot of attention. Recently, if we go back a few years now, there were a number of reports released. The one of particular significance, of course, was the IPBES Global Assessment of Biodiversity and Ecosystem Services. For those who don't know, IPBES is the Intergovernmental Platform for Biodiversity and Ecosystem Services. So that report was released in, I think, 2019, and along with, various other reports around that time, had a really big impact in terms of raising awareness that we are in the midst of a global biodiversity crisis. The extent of that raising of awareness, I think, was quite strongly reflected in the World Economic Forum's Global Risks Report, the one that came out in 2022, actually listed biodiversity loss as the third highest risk to humanity over the next 10 years. I think that's a really significant outcome there in itself. And then we've seen various responses at various levels, both in the public sector and in the private sector over recent years to this raising of awareness, and a whole range of international pledges, agreements, initiatives, and so on. Just a couple to mention there: the Leaders Pledge for Nature, also the G7 Leaders Nature Compact. Okay, so in parallel with all of that, there's been an increasing demand for good data and good information on biodiversity change, and so this demand's really been coming from a number of major sources. I've just shown a few of them there. Perhaps the most obvious one right at the moment is the post-2020 Global Biodiversity Framework from the CBD, which was adopted just a couple of months ago now in Montreal. And so that framework places a very strong emphasis on the use of indicators to monitor progress in the achievement of the global goals and targets that have been agreed as part of that framework. And then from the corporate sector side, a whole lot of initiatives going on there. Probably the most prominent is the Task Force on Nature-related Financial Disclosures. And again, within that process, there's a lot of focus being placed on the development and adoption of metrics for reporting on and making decisions about biodiversity. And then the third one I've got there is the one that we're really going to be focusing on for the remainder of this talk, which Doug's already mentioned, which is the ecosystem accounting framework under the UN system of environmental economic accounting, or what I will just refer to as SEEA from here on. Okay, where does biodiversity sit within the UN SEEA? Well, if any of you have ever looked at the actual document, and it is a very long document describing that framework, then you would probably know that it takes a while to find where biodiversity is actually addressed in there. You've got to get all the way through to Section E after about 250 pages of reading before you get to Section E on applications and extensions of SEEA, and within that there's a chapter 13 on accounting for specific environmental themes, and this is what they call the thematic accounts. And one of those thematic accounts is accounting for biodiversity. But really, out of that big document of 300 plus pages, I think there are only about 6 pages, as you can see there, that are actually devoted to accounting for biodiversity. So most of the ecosystem accounting framework is actually focused on accounting for things like ecosystem extent, condition, and ecosystem services. Okay, so when you look at those 6 pages within the SEEA document, there is a description in there of some of the major approaches to accounting for biodiversity, the different ways that change in biodiversity can be assessed and reported. A lot of that draws heavily on earlier work, particularly an expert workshop hosted by UNEP WCMC, the World Conservation Monitoring Centre, that was held back in 2016. I was a participant in that workshop, and that resulted in the report. You can see they're exploring approaches for constructing species accounts in the context of the SEEA. And then there was a scientific paper also shown there that reported some of those outcomes. Now, there are some broad approaches that have been suggested in that report, and they're all picked up in the SEEA framework document. These broad approaches each have strengths and weaknesses. None of them are perfect, and they're in fact highly complementary and should, wherever possible, be combined together. If we just go through what those three broad approaches are, first one is all about looking at change in the assessed conservation status or extinction risk of species. And so this is an approach where at multiple points in time, species are assessed in terms of their conservation status or extinction risk, for example, using the red list approach. And that's by repeating that assessment over time, that allows the reporting of change in the overall status of species within any given area of interest. Now the strengths of this approach are that it really allows the consideration of the full range of threatening processes operating on biodiversity. It also allows incorporation of a lot of expert knowledge, which is often hard to actually integrate into these sorts of processes. And but it does have some weaknesses. These are primarily that it's an approach that works reasonably well at sort of broad spatial scales, reporting on change for whole countries, for example, not quite so well when you get down to more regional or local scales. It also requires, as I said, the repeat assessment of all the species in the area of interest, which can be quite onerous. And also another potential problem is that species have to move whole categories of conservation status before that will have an impact on change in this overall index. Okay. The second major strategy is one of direct observation of biodiversity change. So things like the Living Planet Index, where people have gone back to the same site in the field repeatedly over time and recorded changes in the presence, or more often abundance, of species at those locations. So a clear strength of this approach is that it provides very direct information on what's actually happening to biodiversity on the ground. The big weakness, though, of course, is that those sites are often very sparsely distributed, and therefore we have grossly incomplete geographical coverage. Then the third approach, which is the one that we're really focusing on in this talk, is what we call habitat-based assessment of biodiversity change. And this is this idea of actually combining remotely mapped change in habitat condition over time with information about the distribution of individual species or the distribution of ecological communities. And those distributions of ecological communities might be in the form of discrete classes like ecological community types, or it might be information on continuous spatial patterns in community composition, which Carell will be talking about shortly. So these approaches, the real advantage of them is that they can be applied relatively quickly and cheaply at quite fine spatial resolutions. The main disadvantage is that the measure that they provide is always an inference about what's happening to biodiversity. It's assuming that change in habitat condition will in fact impact on biodiversity itself, and therefore biodiversity will change as a result of change in habitat condition. Ideally, an approach like this needs to be coupled with a certain amount of field-based survey information as well to help calibrate and to validate these inferences over time. Okay, just one last slide from me. One of the benefits of the habitat-based approach to biodiversity assessment within the broader SEEA framework, or within that context, is that the other accounts that I mentioned earlier within SEEA, particularly ecosystem extent and condition accounts, provide very much the information that are needed to drive this habitat-based assessment. So this kind of approach to biodiversity accounting really provides a great means of integrating biodiversity accounts directly into the SEEA framework and linking them up with ecosystem extent and condition accounts, rather than sort of having biodiversity accounts as something that's rather disconnected from the rest of the framework. But Karel's now going to talk about a case study application of this approach, which I think will bring many of those ideas to life. So I'm just going to stop sharing here and make Karel the presenter and hand over to you, Karel. Thanks very much.
Simon. Screen, yeah. See that slide that Simon left us on. Yes, hi everyone. My name's Karel Mokany, based in Canberra in Australia. Okay, so I'll just give a quick update, I guess, where ecosystem counting is in Australia. So Australia's actually been a bit of a leader in terms of environmental economic accounting, developing all the way back to the year 2000, starting with water accounts. So in a way, I think Australia's been pioneering some of the approaches to generating and communicating and informing, I guess, the shape of the SEEA guidelines on environmental accounting. More recently, the Commonwealth Government in Australia coordinated the development of a National Strategy and Action Plan in 2018, and that was really instrumental in this garnering support and action on moving ahead with ecosystem accounting, and it's led to the development of a variety of pilot projects, testing, exploring, and demonstrating ecosystem accounting for a number of regions across Australia. And so, as Simon said, I'll be talking about one of those case studies, which is the Murray-Darling Basin, but there's also been previous work in other regions, marine and terrestrial, and ongoing pilot projects, including ones that we're involved in. And I guess currently these approaches are being explored in terms of testing methods which can be scaled nationally to develop those national environmental economic accounts for ecosystems. Okay, I'll just throw in, this is a bit of a quick view of where some of that thinking in terms of environmental economic accounting in Australia is going. This is an in-development dashboard for viewing some of that environmental economic accounting information across scales in Australia, so an explorable map package. But I'm going to focus on our case study for ecosystem accounting and biodiversity accounting in the Murray-Darling Basin. So for those of you who don't know where that is, this is the Murray-Darling Basin in the yellow polygon here. So it's Australia's largest catchment, with Australia's largest river system. So it spans a wide diversity of environments in Australia, from alpine to arid, including diverse ecosystem types, floodplain forests, grassy woodland systems, wetlands, and supports a wide variety of biodiversity, as well as a wide variety of agricultural industries as well. So a lot of grazing as well as irrigated agriculture. So it's a large area, so it's 1 million square kilometres and 14% of Australia's land surface. So it's actually a much larger proportion of Australia's agricultural industries occurring here. So 40% of our agricultural revenue comes from this area. So it's obviously very important from an agricultural and land use perspective. But water is a limiting resource in Australia, usually, not this year as it turns out, but usually it is. And that's where some of the challenges come in terms of managing the environment, along with having 5 state territory jurisdictions over this basin. So understanding what's happening past to present is really important in terms of focusing future effort in terms of how we manage this area. So in terms of our biodiversity accounting for the Murray-Darling Basin, we looked at 2 different levels, broad levels. So we looked at developing approaches to understand biodiversity at the species level, and within that looking at focal species, so where we're interested in particular species, as well as looking at all threatened species together. And I'll walk through examples of that. And then at the community level, as Simon said, we can also undertake these biodiversity assessments. And so I'll provide examples of where we looked at waterbird species richness in a biodiversity accounting context, as well as really what the focus of our research is really on is estimating species persistence at the community level. So being able to have a single index for a whole large taxonomic group such as vascular plants. So I'll walk through these different features, biodiversity features, and different approaches for each of these features that we can use in this habitat-based biodiversity accounting approach. And just to, I guess, paint in a slightly different way how these habitat-based approaches work. As Simon said, it's really about combining 2 really important bits of information. So the first is habitat condition for biodiversity and how that's changing with time, and that's relies heavily on remote sensing, as Simon said. But really crucially, it's combining that information with our understanding of biodiversity patterns at either the species level or the community level. And so this is where a lot of that really important ecological information can come in and either be directly used or be spatially encapsulated in the form of biodiversity models, which tell us about these expected patterns in biodiversity. And we can use these for any set of ecosystem accounting areas to develop biodiversity accounts. So in terms of the Murray-Darling Basin, so most of the examples I'll show are accounts for the whole basin, but we also undertook accounts for areas within the basin, and that's really the benefit of the habitat-based approaches. We can split up and look at any ecosystem accounting area and develop an account for any set of ecosystem accounting areas very quickly and easily. So starting at that case where we might be interested in particular focal species. So in this case, we selected 10 focal species. So these are, I guess, across a range of biotic groups, across a range of threat levels, from endangered to least concern, and include some, I guess, ecosystem dominant species that we might be interested in. So particularly the 2 tree species, river red gum and black box, are important ecosystem dominants. So just in terms of the methods of how we went about estimating biodiversity accounts for these focal species. So it really starts with, I guess conceptualizing the pre-intensification biodiversity patterns. In Australia, that's quite simple. We look at a pre-European settlement estimation of biodiversity patterns, and using that information we have, estimating this for the focal species, their potential historic extent of occurrence. Now, with obviously human use of the landscape, the habitat for biodiversity has changed. Here we're just having a cartoon example where we've completely lost areas of habitat for biodiversity, and so the suitable habitat for the focal species can be estimated, and that's not everywhere where we've got habitat. It's everywhere where the habitat is potentially suitable for that species. So in this example, this bird species might need tree cover, for example. But we need to combine that with that initial bit of information on the potential extent of occurrence for the species. And this gives us the key ingredient to this sort of account, which is both the potential extent of occurrence, and within that, the area of suitable habitat within that extent of occurrence. And using that information, for any ecosystem accounting area, we can then get a metric on what's the area of suitable habitat at a particular point in time for the focal species. And so the habitat condition in this case, we used remote sensing of land cover, and basically for each focal species, identifying what land cover attributes were indicative of suitable habitat for those focal species. And the biodiversity patterns in this case came from estimates of the original extent of occurrence for each species, which comes from the Commonwealth Government product primarily. So for our 10 focus species, they cover very different areas in terms of the Murray-Darling Basin, and have, I guess, very different amounts of that habitat, of that original extent of occurrence that is still available habitat. So these are the maps, which are hard to see. Zoom in on one example here, which is the superb parrot. Here, for most of the accounts for the Murray-Darling Basin, we looked at 2 time points. One was 2010, which is essentially our opening account, and the other was 2015, which is our closing year for the account. And so for the superb parrot, we can basically condense all that nice spatial information, which for the Murray-Darling Basin, most of our assessments are at the 100-metre resolution spatially, and we can depict that as a biodiversity count on the right here. So we've got our opening measure, and the units are, the measure here is that area of suitable habitat in thousands of hectares. We can split that up into, over that time period from 2010 to 2015, how much of that habitat has been added, how much has been lost, and what the net change is. So for this species, there's an increase, estimated increase in that area of suitable habitat over this time period. And we can do that for all the species, obviously. And I guess the picture here was over this time period, for most species, we estimated an increase in their area of suitable habitat, with only one species decreasing. Now, I guess in terms of this approach, I think it is useful where we do have particular interest in certain species, but as you see here, the more species we're interested in, the wider this table will get, and at some point it becomes very difficult to synthesize what's happening across those species. And so that's where our other approaches really try and condense that, I guess, to generate single metrics across a broader range of species. And so that starts with looking at all threatened species together. So in this case, again, we start with our picture of pre-intensification biodiversity patterns, and as with the previous metric, estimating that potential extent of occurrence, pre-intensification extent of occurrence for all the threatened species. So in this case, it was about 1,500 terrestrial threatened species in Australia. What we do is we combine all those. So we basically add all those up to get, for every location, the estimated number of threatened species occurring in that location. As with before, we consider habitat conditions. So in this case, I've just conceptualized that as either habitat or non-habitat, but really we look at a continuous metric of habitat condition, which I'll talk about in a minute. And the final step is really combining that information on the number of threatened species estimated to occur in each location with the habitat condition of that location to give us current threatened species habitat. And then for any ecosystem accounting area, we can then sum essentially the amount of threatened species habitat. And so the units here we use are species hectares. So if we've got 10 threatened species in 1 hectare, that's 10 species hectares. So the habitat condition ingredient is really important in these approaches, and in Australia we've spent quite a bit of effort on this topic, and developed, led by Kristen Williams, developed this habitat condition assessment system, which we call HCAS, and it's really trying to best map habitat condition over space and over time, and results in a score between 1, which is estimated habitat in reference condition or pristine or near pristine, down to a score of 0, which is no capacity to support the species originally occurring in that location. And the key ingredient in terms of remote sensing is MODIS data for HCAS at the moment, and another key ingredient is a set of reference sites where we're quite sure that those locations are currently in that reference condition. I won't talk about how the algorithm works. You can explore it in this very comprehensive report I'll link to here, but it's basically our best information at the moment in terms of the spatial distribution of habitat condition in Australia. And so for the threatened species account, this is draft outputs from an ongoing project, but what we're able to get is a spatial picture of change in habitat for threatened species. So in this, on the right here, the green is where there's an increase in that threatened species habitat, and the brown is where we're reducing that threatened species habitat. And the account, in this case, over 2017 to 18, we have slight increase in habitat for threatened species. So that's a single metric which gives us an indication of how we're going in terms of providing habitat for our nationally listed threatened species. So at the community level, we can look at different metrics. I'll start with a very simple one, which we implemented for water birds, which are of particular interest in terms of the water management in the Murray-Darling Basin. So here we implemented a very simple approach, which was looking at dynamically estimating water bird species richness. So it's a really simple approach to looking at biodiversity, habitat-based biodiversity accounting at the species, at the community level. This is the sort of patterns we get, which are quite interesting and intuitive. So our starting year in 2010 was quite a wet year, so there's quite a lot of habitat for water birds, and you can see that reducing to 2015. And we can encapsulate that in our biodiversity count here. So our net change here is a reduction in habitat across that time period. Much more interesting from our perspective is looking at community level biodiversity accounts in terms of estimated species persistence. And this example is for all vascular plant species across the Murray-Darling Basin. So here we're using our habitat condition, HCAS approach, which I just talked about, to provide our picture of habitat condition. And we're using biodiversity models to inform that picture of our expected patterns in biodiversity across the region. And these are two biodiversity model types. One is modeling species richness of communities, and the other is the similarity between pairs of locations. So this, I'm not going to spend a lot of time on how this this metric works, but I'll just give you a bit of a flavour and some pointers. So again, we start with our concept of a pre-intensification of biodiversity patterns. We model species richness based on our data of biodiversity, and we also model compositional similarity. This is using a technique that Simon developed called generalized dissimilarity modeling, and it gives us an idea for any pair of locations how different they are expected to be in terms of the species assemblage at each of those locations. So in this case, it's viewed in terms of the similarity in colour. So we've got a similar colour, we expect a similar composition, and vice versa. Again, we bring in our habitat condition information. To estimate for each location, we combine that with our compositional similarity to estimate for each location the proportion of the species that originally occurred there that are expected to persist in the long term, given the habitat in that location and all other locations, bringing in the similarity to that location. So that then enables us for any ecosystem accounting area to estimate the proportion of species in that ecosystem accounting area that we expect to persist in the long term, given the original patterns in biodiversity and the changes in habitat condition for biodiversity. So in this cartoon example, we're estimating that at 76% of the species originally occurring in this ecosystem accounting area expected to persist in the long term. We can also estimate that the number of species in that ecosystem accounting area to get an estimate of the number of species. So we're turning that proportional percentage into a number of species expected to persist in the long term. And so this is the picture for vascular plants across the Murray-Darling Basin. So the darker green colours are where we're expecting a high proportion of the species in those locations to persist in the long term, and they relate to areas that are less intensively managed, and the lighter locations where we're expecting less of the species in those locations to persist. And so we can, for any ecosystem accounting area, that the numbers here are for the whole Murray-Darling Basin, we can derive those numbers on the number of plant species expected to persist. So there's, over the whole basin, we expect originally about 6,200 plant species occurred. And here we're estimating the number of those species we expect to persist over the long term into the future, given how we've changed the habitat. So here we've got a slight increase in our expectation of how many of those species are expected to persist. So we've looked at different biodiversity features. We can also, I guess, then combine that and look at how we can synthesize, well, what's happening across this whole region. And this is, I guess, our first attempt to try and do that. So here we're looking at ecosystem accounting areas in terms of regions within the Murray-Darling Basin, and combining our biodiversity accounts for different elements, different features of biodiversity, and looking at areas where those are more consistently increasing or decreasing, which gives us a picture, in this case, of the northern regions tending to have more decreases in the biodiversity features across this time window, and southern areas tending to increase. And this sort of information starts then getting at more tractable, usable information of, for example, where we might target environmental watering actions across the basin. And this work, as I mentioned, is published. This is the paper We've also got some more information on our environmental accounting, ecosystem accounting work at this link here. So just summing up, I think as Simon pointed to, the habitat-based biodiversity assessment approaches, there's a lot of benefit in these approaches in terms of ecosystem accounting, particularly the scalability of the information. The community level approaches, I think, are particularly useful in developing a single metric which tells us about a very large number of species. So it avoids that case of having to look at every species individually and then somehow combining that information to get an idea of what's happening. There's still the challenge of biodiversity is amazing and complex, and here we've just looked at a small facet of that, and so how we get that picture across other biological groups is a challenge, and we need to keep working on improving our information that we can use to be more representative across those biodiversity features. That habitat condition ingredient is really important in this habitat-based approach, obviously, and so we're continuing to work on improving that for Australia and for the world, and that's a key need across these approaches wherever they're applied. I guess a benefit of the SEEA is the potential to understand, both understand reasons for change. So where we're predicting a reduction in biodiversity in a particular area through these accounts, being able to bring in some of that other information that's developed in the SEEA accounts to suggest why that's happening, as well as potentially to help identify what are the implications of the changes that are occurring in biodiversity here. Are there less tourists visiting particular locations, for example, because we've depleted the biodiversity in particular areas? And just finally, there's real utility, I think, in these biodiversity accounts to link together the traditional biodiversity accounting information, which is past to present, with a forward-looking view where we can start using that, I guess, the picture of current status to then identify the likely implications of alternative management actions into the future. And I'll just give you a quick picture of how one way that we're doing that in our team, which is a web tool which is really demonstrating how this same metrics that we use for biodiversity accounting at the whole region scale can be applied right down to the farm scale and can be linked with forecasting. So in this case, we're looking at an individual farm, a potential management action, environmental planting, and what the implications might be for biodiversity when we undertake that action, given where we know or where we estimate biodiversity to be in terms of this location to start with. So just finishing up, I think there's real opportunity for biodiversity accounting as it matures to really help biodiversity conservation and linking that needs of reliable information across scales and across different decision types. I'll leave it there, Doug, and I'll sit back to you.
Great, thank you so much. That is a great example of how to, very creatively manage large dimensionality. Right. So I love seeing you guys, take the big maps and the large data flows and find ways to efficiently analyze it and produce something that informs, trends and potentially policy and decision making. So I think that's great for us to see. And gosh, I guess I'd like to open it up to others for questions. If anybody would like to jump in, I guess as a segue, I'll provide a question as a segue here. So for us, there's a lot of debate about how to invest in biodiversity, right? So we see the I'm sorry, the SEEA, as a way to do policy analysis. Are you guys planning to look at any specific policies in Australia with the SEEA in the future?
Do you want to have a go, Simon, or I could start? We don't have any. Yeah, you go.
Oh, okay. Yeah. Look, we can't comment too much on policy matters within Australia, Doug, and you know, I think it's fair to say we're at a very interesting point in Australia now where there are a number of new policies being developed and whole new programs ramping up, you know, including around, you know, things like markets and so on, and credits and those sorts of things. But that's sort of work in progress within our federal environment department at the moment. So it's not really the right time for us to be saying too much about that. But I think it's fair to say that, you know, these same approaches that we're talking about here, applying within the SEEA context, do have potential applicability to other initiatives that are and programs that are developing within Australia around things like markets.
Okay, great. Yeah, thank you for highlighting that. So we have a question from Michael Gardner. Michael, you want to unmute yourself?
Hi, thank you. I'm in California, and wonderful presentations. Thank you very much. And just to follow on to that last comment from Dr. Ferrier, it sounds like there is then potential to be able to use these methodologies and techniques to actually originate, say, biodiversity credits, because being able to originate those credits and sell them becomes an important finance technique to be able to finance the preservation activities. So I guess the question is, do you know of a case where that's been done using these techniques? And if not, am I thinking about it correctly, that there is potential to use these to do that? Or am I thinking of it wrongly, do you think? Thank you very much.
Thanks, Michael. There's indeed a lot of potential, but as I said, you know, we're still a way off actually, you know, having that policy implemented. You know, the legislation's hasn't even gone to Parliament yet. It's still at an early stage within Australia, so there hasn't really been the opportunity yet to explore closely how approaches like this might contribute to the implementation of, you know, credits or market instruments more generally. But in terms of whether there's anywhere that these particular approaches have been applied to a credit scheme, I'm not aware of any existing application, but Carell might be.
I'm not aware either. I guess I'd only throw in and agree with Simon that there's certainly potential to use these approaches, but I think they need to be considered and used carefully. So, you know, our job as scientists is to continually improve the information, and that can mean changing our estimates, for example, of habitat condition in a particular place. And so there's implications in how those changes or improvements in estimates might flow through to programs that are monetizing or marketing the potential improvements in habitat condition in places. So I think, yeah, there's certainly opportunity, but it needs to be it would need to be done with care and considering those potential improvements in information. I guess that just throw in the potential benefits of using these sorts of approaches for that are that they can be integrated with jurisdictional biodiversity accounts, and so I guess have a coherent picture of how different initiatives and actions are actually adding up at different scales to support biodiversity.
Great. Yeah, I think it represents a great way to organize information. And then, as you said, Carol, like to actually look at a trade in a market, you would want more detailed information to estimate equivalence within that policy. So we have another question from Marlene. Marlene, you want to go ahead and unmute yourself?
Sure, thanks. More of a comment than a question, but so I'm in California in the United States, and we have several different types of programs and initiatives out here on conservation planning work and how they integrate with different permitting frameworks. So for example, the federal U.S. Fish and Wildlife Service and the state wildlife agency have different sort of habitat conservation plan approaches, HCPs and CCPs, where they figure out where different critical habitats are, suitable habitat for species, and they come up with acreage goals that they want to make sure that they add to their plan areas. And then as developers impact areas within that plan, they have to pay a fee or do mitigation within that. So that's kind of an ability to feed this kind of work, which is basically putting that map together and having that feed into a framework for credit trading. Similarly, I think it's the Nature Conservancy. They're doing pretty large scale like green print plans in Northern California, and they're working on one in Southern California right now, and they're trying to incorporate those with land use planning efforts to make sure that we're, focusing future development on areas of low conservation priority and away from areas of high conservation priority. But I'm sure there could be, one way that we've sort of looked at that is, where are the areas where it might be good to site mitigation banks that fit within sort of high priority conservation areas that meet different conservation goals while also being, that you can monetize them. Sorry. So anyway, just to comment on that, this is really cool stuff. There's all kinds of cool habitat suitability modeling work out there, but this seems pretty interesting. I'd be interested to see how it integrates with climate forecasting as well, to figure out where we should focus on conservation work for refugia in the future.
Yeah, could I just pick up on that very quickly? Thanks, Marlene. Yeah, just wanted to make the point that in this presentation, we're very much just focused on the accounting applications, which is largely, as Carol said, a past to present perspective, very much monitoring what's happening to biodiversity up to the present day. But a lot of our other work in our team is actually concerned with more with planning and prioritization of actions into the future, which is all about future projection of what might happen as a consequence of potential actions in the landscape. And a big part of a lot of that work is bringing in climate change as well. So what we've talked about today is really just the tip of the iceberg in terms of how we actually apply this other class of techniques to accounts in this case, but we've got a whole portfolio of other activities where we apply similar approaches to things like planning and prioritization and future projections and scenarios and so on. So thanks for that.
Do we have more questions? All right, so hearing none, I want to thank you both. Simon and Carol, thank you so much for that great presentation. It really helps us to think forward in terms of our data sets and our activities and policies. And I just want to leave you guys a minute if you want to say something in closing.
Oh, and only to say thanks very much for the opportunity, Doug, and really good to talk with you again after what must be quite a few years since we last.
I think 10 years.
Yeah, that's right. So thanks very much. I'll let Carel say something.
Yeah, no, thanks a lot. It's always good to share the work that we've been.
Great. Well, I look forward to seeing you guys in the journals. Thank you so much.
Cheers.
Thank you.
All right, cheers.
Thanks very much. Bye, everybody.